Mhm. Hello. So in this session, I'm just going to be going over the basics of Unity. So we're just going to be setting up a new project. I'll be going through the user interface of Unity. So what each window on the actual project does. We're going to be going over creating objects and materials. I'm going to be going over what components and game objects actually are in Unity. And then we're going to, at the end, just be going through moving an object by script. So in Unity, you can do stuff like moving objects around based on stuff like user input, or if you just want to say at the start of the scene, you just move it in a certain direction. So we're just going to be going over basic stuff like that. So first, if you want to make a project, just open up Unity Hub. On the left, there's this projects thing, and you can just click New. That opens up a 3D window, and it has 3D here. You can write a project name it whatever you want, say test project, or you can just name it the new Unity project and click create. So while that's creating, I'm just going to go to the next slide. Unity is basically a game engine. It's used for a lot of things. It's used for 3D games such as Subnautica and Kerbal Space Program. It can also make 2D games. A notable one is Cuphead. On the bottom left here is a picture from a VR application that someone's made. So Unity can also be used to really easily make VR applications, and also an AR one over here. So a VR application is where you'd have the headset on, and then you can actually interact with the project with your two controllers, as you can see here. And the AR, which is the augmented reality, where you can have, say, a phone or a tablet, point it in the real world, and then have access to, say, more information or stuff like Pokemon Go. So to start off with, this is just what the default user interface of it looks like. So you can drag windows. I'm just gonna drag it to how I feel is the best. So you can just click the tab here and just drag it under the hierarchy for the project. For the console, I'm just gonna drag it over to below the inspector. And this will allow the scene view to get much bigger. So you can see more of the scene. And I'm just gonna drag the game view to the side over here. Also, I'm just going to click on project view with the three little dots and just click one column layout, and that will just make the whole user interface much more organized than it was before. Okay. Just get back to that. Oops. Okay, let me just open this up again. Ignore that. I just closed it by accident. Okay, so this slide just says how you can just sort of click on the tab and then move it around. So for Unity, there's these windows, as you can see, because they're these colored boxes. Each one of these is a different window in Unity, and they allow you to do different things. So the hierarchy, it allows you to see all of the objects in your scene. So say if this was in the game, you'd see all of the objects for that specific level. The projects one it just holds all of the assets for the entire project. So if you have, say a game, it shows the assets, so the models, the materials, scripts, and everything like that. It will show all of them that you can use for the entire project. The scene view allows you to see the actual scene. So a scene in Unity is just like, say, a level in the game. This allows you to visualize what's going on, so you can see everything that's actually happening. The game view shows the what it's like to see from the camera's perspective in the game. So say you were playing a first-person shooter, this game view would show you what you'd actually see when you play the game. The inspector here, it allows you to change properties of different objects, which I'll go into detail later, but say you want to change the position of, say, the main camera or something here, you can go over here, and there'll be a bunch of stuff that allows that to happen. And the console, it can show you, it's pretty versatile. You can use it to say, if you have an error with a project, this is where it shows. And it can also, say you have a script and you want to see what's happening at certain points of the script. You can print it to the console here, and this is where you'd see it. So we're just going to go through creating folders now. So to create a folder, you just right click over here on assets, you click on create, and you click on folder. And then I'm just going to create a few basic Unity folders just so you can organize your assets in the project. Name that materials. I'm going to right click on it again. I'm going to name it models. I'm going to name one called prefabs. I'm going to go into what a prefab is in a bit. And I'm going to name one called scripts and one called textures. So these are just the basic folders, because when you have like a big project and there's lots of assets in it, it helps to keep it all organized. So you don't have to just keep scrolling to find what you're looking for. You just have it in the designated folders. Now I'm just going to go through creating game objects. So as you can see here, there's just a main camera and a directional light. So these are game objects, and the game object is just anything, like any physical object in the scene. And the game object, basically, it has components, which I'll go into in a bit as well. It has, say, a transform component. This camera has a camera component, whereas a directional light has a light component, other stuff like that. So to create a component, you can click either create empty to create an empty component, which you can give more components to. I mean, an empty game object, which you can give more components to later. Or you can actually create one of the primitive types in Unity. So say you want a cube, a sphere, capsule, a cylinder, you can just do those as well. There's also stuff like lights. So if you want a light in the scene, audio sources, UI, stuff like that. I'm going to create a 3D object of a cube, and this will bring a new cube in here. You can also rename it anything you want. But I'm just going to keep it as cube. So when you create a cube, you can see that now there's transform here. There's all these things you can do. So say you can, if you want to change the each specific coordinate manually, you can. So if I want to have an X position of 10, you can see that it's now moved here. Also, I'm just going to create a second cube here. I'm going to name it plane. And I'm just going to change these, the Y position to -2 to put it down by 2 units. I'm going to change the scale. So the scale is how like stretched out you have it. I'm going to change that to 10 on the x-axis. You can see it's all stretched out now. If you put it to 10, the Y I'm going to keep as 1, because if you have it bigger, it makes it larger on the y-axis. So I'm just going to keep it pretty thin right now. And the z-axis for scale, going to make it bigger as well. The rotation is what controls how, like, what axis they're rotated on. So if you ever want to just rotate something in Unity, you can use these. And to clear it back to default, you can right click on transform and just rotate the rotation. You can just reset it, all the same for position and scale. Okay. So now for this part, we're just going to be creating the materials in Unity. So to do that, you have to go over to the materials folder, and just right click and create. This will create a new material if you click on that. You can name it whatever you want. So I might just name it cube material, just so you know, when you look back on it, you know what it does specifically. Here, when you click on it, to the right-hand side in the inspector, you'll see that the material things appeared. To change the color of it, you can click on the color on this little box here, the white one, and change the color to whatever you want. So I'm going to change it to red, and you can see that it's been applied to the material now, because you can see it here and here. And I'm just going to click on the left on the cube material and just drag it into here. And when you've clicked on the clicked and dragged it in, you can see that it's now changed to become red. You can also just change it to anything, any color, and any object that has the material on it will also change to the color that the material is. Materials also have specific stuff like metallic, so that's just if you want it more metal-like, I guess, and smoothness, which makes it more, just depends how light is reflected on it. I'm also just going to go quickly to the window, and I'm going to go to rendering and just find lighting. I'm going to find this lighting tab. I'm just going to click generate lighting quick. This just creates lighting in Unity and everything's calculated and it just looks much better. Now you can see that this cube is also more smoothed out if you have the smooth slider set all the way up. Okay. And you can also do the same, say if you want to have one on the plain material. If I just drag it on, change the color to whatever I want. Say if I want a slightly green one. And then I'll have the smoothness down, and you can see that the plane's actually a bit green now. So this just says right click here, create material, and then that little box is what changes the color of the material. So in this section, I'm just going to go through what a component actually is in Unity. So they're basically just sort of like properties that you add to any object in Unity, and that you can give it functionality. So each game object comes with a transform component already. So this handles the position, rotation, and scale of each individual object. So here, and also components can be they can be changed by scripts. So a script is basically just like a piece of code that you write that when you run it in the actual game, it can do certain things, such as say make something invisible, move the objects about, stuff like that. The mesh renderer, it has information about how the model is rendered, such as what materials it has, things like that. And if I go back to click on this cube, you can see that there's a transformer mesh renderer here. If I just untick mesh renderer, you can see that the object's still there. You just can't see it anymore. There's also a box collider. So this allows the object to collide with other stuff in Unity. So if you want, say, like a more physics simulation where boards are being hit by stuff, and with physics simulations, you can do that, which I'll go through in a bit. So now I'm just going to go through the section where you use components to make a physics object. So I'm going to click on cube. I'm going to click on add component, which you can do by scrolling down if you don't see it. Or you can also close these components slightly so you have access to it now. And I'm going to type rigid body. And now this will add a rigid body component to it. So a rigid body basically just handles the physics sort of control of it, I guess. So like It can do stuff like make it fall, make it interact if it collides with something, make it act like it would in real life. And it has all these things that, which, such as mass, use gravity, stuff like that, which can make it. You can fine tune it to behave like you want to. And then once that's in, if there's both a box collider and a rigid body in the scene, you can press play at the top and you can see that the cube will now fall because it has gravity. So you can just do these sliders to move the object about in Unity. As you can see here, there's also in the top left, the this sort of icon is for the movement of the object in Unity, which you can do in scene view. This one's for the rotation. So if you click the rotation one and then drag these any of these axes around, it can just rotate it on the fly. You can also do it here in the top right in the hierarchy, in the inspector, I mean. And same for scale. If you want to change the scale at any point, you can do so. The only thing is, if you make changes to an object in play mode, when stuff's actually being run, those changes don't get saved. As you can see here, it's gone back to normal. Whereas if you change it here, it actually stays like that. You can also see that if I close the box collider, make it just like disabled, and it still has a rigid body, the object still falls, but now that it doesn't have a box collider, it just passes through everything. So this is the slide where you just add a new rigid body component to your object.
Anyone has any questions so far?
This is Sai. I have a question.
Go ahead.
Can you go back to the slide ones, the scene ones?
Which one?
The scene, the Unity scene.
This one?
No, not the slide. The Unity editor.
Yeah.
So the question is, if I want to do the manipulation of rotation and resizing, not in a play mode, but if I set the properties, will the properties hold good in the play mode?
In play mode, anything that you do just it doesn't stay like that. It's just when it's not in play mode, this is the initial state, and anything you make in play, any changes you make in play mode, they're just temporary. So they're just to say, if you want to test how something would work, you can just make those changes here. So say if I just rotate that, you can see that it falls off, but when I exit play mode.
Yeah, so if I want those permissions or the features to hold good,
yeah, you'd have to do it outside of play mode. So say if I'm just not playing right now and I make some changes here, say I want the cube to be like that, and I click play mode, now it's how the actual project will run.
Okay. So can I pick it up now in the play mode? Can you play it once?
Yeah, you can play it, and now these are the changes you've made to it. So this is how it will stay now, and then now you can change it however you want. So say if you want to just rotate it some more, you can.
So I don't need to write any custom code to hold it up, pick it up and throw it, because the gravity is enabled. It will take care of those physics aspect. Is that correct?
Right now you can, but it's just for like testing mode. So if you just want to test how it would work. But if you want to have like an actual project where there'll be like if you want to have it just be able to move by WASD, say in like specific directions, then you'd need to have an actual script, which I'll just go into in a bit on how to do that.
Okay, great.
But like from what I understand, just adding that collider, for example, so that physics aspect, it gave the object the ability to have like physics, like, you know, gravity affecting it without us having to code that, right?
Yeah. Because say if the rigid body wasn't in here, it just acts like a static object where it can't actually do anything.
Yeah, cool.
But the second you add a rigid body, it now starts behaving. You can also do stuff like turn off gravity. So if you uncheck use gravity and then you say rotate it to collide with something, it will just sort of float away. Yeah.
Interesting. What if we want it to stay still and not float away, but not fall down either, just like kind of float in the air?
There is this is kinematic mode, which I haven't used it that much, but what it can temporarily just disable like physics interactions just for a bit, but keeping it as a rigid body. So if you
Okay.
if you do that, it's still that, but
Or maybe if we don't add a rigid body at all, would the object just stay wherever we put it in the first place?
yeah. So if I just reset it back to normal. So this is just the, I'll make a second one where you can actually see the effects of it.
Mhm.
So I'll just name this one physics cube. I'll give it a rigid body. Oops, wrong thing. Oh, I'll just try that again. Oopsie. If I add a rigid body this time, not the other thing I added, I'll put it a bit above so you can see the effects of gravity. You can see that this one falls onto it, whereas this one is just a static object. So it's
Yeah.
basically fixed in place and nothing can interact with it.
Nice, nice.
But if it doesn't have a rigid body, will it not have collisions either?
For
Or
collisions, the box collider is what actually handles the collisions. So I'm pretty sure if say this is trigger, so if it detects something enters the, you can see there's like this green box, green cube around it.
Yeah.
That's what actually handles the collisions. So if something else passes, it's just show here. Something else can pass through it now because it's set to that is trigger. Whereas here it can't. So is trigger just allows stuff to like pass into it. So that's good for, say, if you want to have like an invisible door, like if the player enters an area and you have like this is trigger box and you have it off. So say you do that and then anything that enters here will trigger some script, then that's what that can be good for.
Nice. Cool.
Okay. This section's just about moving the camera in Unity. So the middle mouse button, what that can do, it can just move the camera perpendicular to whatever you're looking at. So if you want to just quickly pan about the scene, you can. The right click, it just rotates the camera on the spot. So if I right click, you can see that it rotates like that. The F key is basically the focus keybind. It allows you to focus on whatever object you've clicked. So if I can have a click on it in the scene view, or actually click on it in the hierarchy and press F, you can see that it now focuses onto that. So like say you're far away from the scene and you want to go back to the cube, you can just click on it and press F and it will go back to it. Also Alt left click, it rotates around the object that the actual camera's focused on. So if you say focus on the plane, pressing F, and then I hold Alt and I press left click to just pan about, it's actually focused on that specific object, as opposed to without Alt, it would just, with right click, it will just do this. So yeah, I can just go back to normal. There's also this little gizmo you can see in the top right of the scene view over here. So that just allows you to snap the camera to specific axis like X, Y, or Z. So say you want to click on the red one, that's the X one, and it will snap the camera to the X axis. You can also do that with the while focused on anything, like so. Same for the Y, which is you see from top down, and the Z one, which is what Unity calls the forward axis. And these other two are like the on the opposite side of the axis. This cube in the middle, that is basically allows you to switch between perspective and orthographic mode. So perspective mode is how you'd actually see the cube in the scene, whereas the orthographic mode, it basically allows you to see the everything in the scene without any distortion. So if stuff is just further away, it still looks exactly the same, like you can see. Whereas here, it's like stuff that's closer is way bigger, and then stuff further out is smaller. So if I put it really far out, you can see they're not the same size, but now now they are. So this mode is actually pretty good. Say you want to build something in Unity and you want the top of every wall to line up, then the orthographic mode allows that to happen pretty easily. Yeah, in perspective mode, you can just see how it looks like in the scene. Now I'm just going to go through the making a new script component in Unity. So the script component, it allows you to just add even more functionality to your game objects. You can also do stuff like moving stuff about, or just more complex stuff. And basically for any complex game to function, or any simple game really, it requires some script components to allow stuff to happen. So on this section, I'm just going to go through making a really basic script. So if I click on add component when clicked on the cube, I can type script in here to make a new script, and then I can call it whatever I want. So I'm just going to call it test script. Click create and add. And then if I just wait a few seconds, you can see that it's appeared over here in the list of components. So this will basically allow you to open it over here. I'm just going to drag it into the scripts folder just to make it more organized. I'm going to open that and double click on it to open it in Visual Studio. And when that's done, I'm going to go through how to just basically just edit a few components in the on runtime when you actually run the project. So this is what you're introduced to when you open up a new script for the first time. This top section is just basically imports packages into Unity. So this will just allow you to, later on when you do more complex scripting, if you want, then you can have stuff in these, which basically like pre-written code that someone else has done that you can use. And this is where the actual code is written inside. So this is the class of the test script that you just created. This is it's a method. So these methods, basically, you can see it says void, and then it has two brackets, two curly brackets here, an open and a close one. You can have it basically the brackets anywhere, but I normally have them on the same line just to make it more organized. And any code inside these is ran when you run the project. So this start a method or function or whatever, I think the functions for Unity is anything inside here is run just once when you start your project in Unity. Whereas here in the update one, it's run every single frame of your Unity project. So if you run your project for say 60 frames per second, then it will run 60 times a second. So I can test that out just by doing a simple debug.log. This start function works. So basically the syntax is debug.log, open bracket, and then speech marks in here if you want to write a message. And then you have to end every line that doesn't end with like curly brackets. You need to be ends with a semicolon. And then if I save that with Control S, and then I run it, you just have to wait for it to basically compile for a bit. Probably shouldn't take too long. And then you can see here, if I click play, now in the console, it says this start function works, which means that the debug.log has worked. I can try the same thing for copying and pasting it into the update. if I do this update function works, it will now say every single frame, which is quite a lot of them. It got up to 999 very quickly. It will say the this update function works. So that's what debug.logs are for. Also, if you want to have your own custom function in here, not just these two, you can. So I might just do void, name it whatever I want, test function, open close bracket, and then open close curly bracket. And then if I want to have like a specific piece of code in here, then that's what functions are for. So say, for example, if you want to have a function that adds two numbers or does more complex math than that, you can have that as a function. And then anytime anything else in the code needs to do that complex math equation or whatever, it will just run the function instead of just having to copy and paste lots of code for several things in the code. So you can see it's grayed out. That's because we need to actually call the function. So you can either call it in the start or update, because these are automatically run. Whereas this isn't run automatically, it's just run whenever it's called by anything else. And I'm going to do a double bracket, and then anything after this point is a comment. So I can just write, say if I want to write what the actual function does, I can do that here. So here I can just say, if I wanted to do like quick debug.log, and you don't always have to have a text on it, so you don't have to have a string. You can also do stuff like 8 plus 2, for example, and then you end that. So this will basically, it will start the program. It will call the test function. It will do everything inside of here, and then say you can do more stuff after. So you can also do stuff like call it several times, and it will just do everything inside here, and then everything inside here again. I'm going to test that quickly by pressing play. And you can see it's printed twice. Is that okay to follow so far?
Yep, this is Sai. I have a question with respect to the orthographic mode. Could you please explain that once again?
So orthographic mode, in the top right, there's the axis gizmo, and clicking on it goes between orthographic mode, which is this mode, which I could probably show you. It's better. It's good for like, if you want to build stuff, say I want to build a wall over here. And say, this is a bit underlined. I can see if I go on here, on this little gizmo, from here, it's sort of like trying to scale it to be the perfect height is sort of hard, because if your camera is a bit too high or a bit too low, it sort of skews it. Whereas clicking on the orthographic mode, you can see the exact height perfectly, and then you can scale it up to the perfect point, so that it all lines up properly. So that's one of the things orthographic mode's used for. It's pretty useful.
Okay.
Do you understand? Okay. So now before I go to the user input, I'm also going to go through changing components by script. So say I want to change the transform over here. I want to change it to say I want it to be start at 10 in the air on the y-axis. I can do that by script. I don't have to do that by manually moving it. So the way I can do this is, let me just get rid of these for a bit. First, I need to actually have basically a reference to what the script is trying to get. So for this, you can either do public and then transform, and then I'll just name it transform. So basically what this public thing is doing is, is when you actually go into your scene view and you've saved your script, and then on the test script, you'll see that there's like a field where you can actually put that specific component in for the script to be able to use. And then to do this, you can just click on the transform and then drag that into the cube. Or another way is if you have like a different transform from a different object, you can just click on the that object in the hierarchy and just drag it in here. And same for the same object. So this can be useful for when there's just lots of objects and you want to drag that into here. Another way for transform specifically is, I'm just going to here what this does. So this is basically saying what type of object it actually is. So you can have stuff in Unity like public game object, which is what it's basically saying that the object you have a reference to is a game object and not just the component. So if you want to have like that, it's basically taking this entire thing, the entire cube itself, as opposed to just getting the transform. So you can just drag that in as well, but not really needed for now. The specific thing about transform in Unity script is that if you just write transform, then that just the script already has a reference to the transform related to the object that the script's attached to. So because this test script has is attached to this cube, doing transform on here automatically gets this transform. So if I just do transform dot position, like so, you can also do other stuff like dot rotation, dot local scale and stuff. I'm going to do dot position equals, and then a new vector 3. So vector 3 is basically just a list of 3 different values, and it corresponds to the X, Y, and Z. So if I do it like so, I can manually change the values. So if you want to do 0, and then 10 in the air, and then 0, and save like so, it will change the transform position to be 10 above 0. And then when it compiles and I press play, you can see that every time it just automatically starts up in the air. And if I just add the rigid body back, and click like so, it will spawn it in the air every single time, and then it will fall back down because it has a rigid body. Also, if you want to have decimal points in these values, you can just do dot, say 125, and then you can press it, and you have to do an F. This F tells the code that this number is a decimal as opposed to a whole number. Since this is a whole number, it doesn't need it, but if I want to get really precise and do 0.2, I would have to do an F. Or you can just have an F even if there's not a decimal number, if it requires a float. So that's that for this. And you can see that when I do those decimals, it will now appear over here as well. With the 0.125 is how much it's been moved on the x-axis. So now I'm just going to go into actually moving the object of user input. So if you want to follow along in chat, there's just the script. Just you don't have to write it out in detail, but I'm just going to copy and paste this whole thing inside this class. Just going to get rid of start and update. I'm just going to paste that in. And just make sure everything's on their own lines. So what this is basically doing is fixed update is like update, but instead it runs every physics frame instead of every every rendered frame. Because sometimes the physics frames are different to the displayed ones, just to make things smoother or less laggy. So when it's like this, there's a public transform camera. So you're basically, for this one, you're giving the you're adding a field over here onto the cube and allowing you to get the position of the camera of the transform component, and this will allow you to move the camera whenever you want. The same for the rigid body. So you can just drag the rigid body of the object itself if you want, like so. And then this private float, so that's how you define basically a decimal point number. Instead of doing private or public transform, you just write float in here, and then this is the name of the variable. So a variable in Unity is basically it just holds a piece of data. So this one, for example, holds a decimal point of 10. That 10 is held inside here. You can also do the same for, if I want a private string, test string, I can call it, this is a test string, like so. And variables can be called from the code at any point, which makes it really useful. So instead of writing how much force you want on each direction of pressing W, pressing A, pressing S, and pressing Z, instead of writing 10 on all of them, if you just want to change all of them at once, you can just do it here. So say if you want to change that to 100, and if I just run the code quickly, over here is what you'd actually see on the game view. So you can see that adding to 100 made it go pretty fast. I'm just going to extend out this plane a bit more, just to make there's more space to move on. And then doing this, holding W, A, S, and Z can move it around now. Now that it's been added in here. So this line, basically, what it's doing is every single physics frame, if you're holding the W key, it will run whatever's in here. So if you hold input.getKey, keycode.w, this is just the standard Unity for doing specific keys. So you can see here, there's also stuff like escape, return, any key on the keyboard. When that's done, it will get the rigid body. And what rigid bodies have, you can do add force to them. So this will add force to the rigid body on a specific direction. So vector 3.forward for W, if I just go back on here, vector 3.forward is this direction. So it will move the cube in this direction by a scale of 100 here. I'm just going to put that back down to 10. And this basically timesing it by 10, since 10's in the force amount, it's going in here. The same's also for S. S is the vector 3.forward, but the opposite of it by doing negative. So for here, instead of doing this way, negative makes it go the other way. And there's also the same for vector 3. If you want to do A, I want to have it go in this direction over here. But since vector 3.right is this direction, I'm going to do the negative of it, and that will make it move here. And the same for D. D will move it to the right. So where I just showed is here. And when I play, you can also see in scene view, you see just from a fixed perspective how each actual object moves. So 10 makes it move a bit more slow. Whereas if you put it up to 100, it moves much faster. And doing D, S, and stuff makes it move about. I can also you can do camera.transform.position. This will get well, you don't need that part because there's already a transform here. But basically the camera's transform, it's getting that and getting the position component of it. So it's getting the camera's position here, and it's moving it based on the position of the cube. So for the position of the cube, it's setting the camera's position to that, and then it's adding this minus 0.85 on the X, 1 on the Y, and minus 5 on the Z. So it's basically shifting it backwards a bit, and like so, to make sure the camera's always fixed to the cube. So if I just reset that, And then you can also do stuff in Unity, such as if you want to get rid of this box collider, you can right-click remove and go on add component. And there's a bunch of other colliders in Unity, such as a capsule collider, a circle collider, a sphere collider. You can do circle colliders and stuff for 2D, but for 3D, I'm going to stick with a sphere collider. And you can see that it's being visualized here. I'm going to make it a bit bigger by scaling the radius up a bit. You can also do stuff like change where the center of the collider is. And now when you actually run it with a sphere collider, even though it's a cube, it uses the physics of a sphere and makes it roll like a sphere. Like so. So that's mostly it for now. Does anyone have any specific questions about anything I've covered in this demo?
No, I think we are good. We should now practice.
Okay. So that's it for this demo. We have our socials on the screen here. And also email and the QR code.
Cool. Thanks, Michael. Do you guys have any questions in general about the society?
So you guys are like a university student group?
Mm-hmm.
This is I.
Yep.
Okay. Okay. So are you guys working on any research in terms of VR?
Yeah, so that's what I was just about to come on to. We've got an opportunity to for students to take part in various projects. Some of them are research projects and some of them are more like hands-on where you make AR and VR apps. And we'll be hosting another workshop 2 weeks from now to tell everyone about the opportunity to get involved in these projects. So we'll be going more in depth about that. But if you guys are interested in getting involved in any of the projects, I've put 2 links in the chat now. In the first one, if you fill that out, just to let us know what kind of projects you're interested in getting involved with, and we'll let you know when we have our next session. And just to kind of see, what kind of event projects the members are interested in getting involved with, so we get more similar projects as well. Then we'd really appreciate it if you could also fill out the feedback form, just to let us know how we did today, and if you'd like to see similar events like this in the future from us. So that's everything from us. If you guys have any further questions, feel free to ask now. Otherwise, that's all from us. Thanks a lot for attending today's session,
you.
and we hope to see you again in the next workshop.
Thank you.